Hi Chem Peeps, let's talk about writing electron configurations. I'm going to have several videos and examples in this series. And the first one I'm going to do is the diagonal rule. Electron configurations are a visual way that we can represent how and where the electrons are found in the atom. Now, the diagonal rule is kind of like training wheels. It's the first way I show the students to get started with this, but the periodic table is definitely the best way, and we will do that in the next video. The diagonal rule I have shown over here on the left. This is the diagonal rule, and it kind of reminds me, I always tell my students, like Chutes and Ladders, the game that we played when we were little. We always start up here at the top and we fill the first chute, which tells us to fill the 1s first, and then we go to the next chute and we travel down, fill the 2s, and then the next zero, 2p, and 3s, and so on and so forth. What's kind of cool about the diagonal rule, and I have it written out here. If I was to follow all those arrows, this is what it would look like. It tells me the order that the electrons fill the energy levels and orbitals. And electrons do not understand a chronological order. We do not fill the energy levels and orbitals in chronological order. We fill them from lowest energy to highest energy. So when we look at this diagonal rule, we see right here it goes 3ps, 4s2, 3d10. And you might be thinking, well, why don't we just fill the 3 up and then fill the 4? Again, it's lowest energy to highest energy. Let's also talk about what this symbol means, 1s2. Over here I have that explained. The 1 represents the energy level. The S represents the electron cloud that the electron is found in. And the 2, the superscript 2, represents how many electrons are found in that cloud. In review, if you haven't already learned this, there are 4 clouds that we're going to work with: the S, the P, the D, and the F. The S is spherical shaped and can hold 2 electrons. The P is peanut shaped and it can hold 6 electrons. The D is donut shaped, or at least one of the 5 shapes are donut shaped, and it can hold 10 electrons. And the F is super duper fancy. It's too hard to draw. There are 7 of them, but they can hold up to 14 electrons. And what's really cool is that on the periodic table we have 7 rows. And those 7 rows correspond to the energy levels that are found in an atom. So right now we have 7 energy levels. So that is why when we look at the diagonal rule, we see the S, P, and D, and F's, and we see 1 through 7. But I have told my students that there may come a time that we discover more elements. And that means we might bump to an 8th row on the periodic table. And if we do, that means that we're going to have an 8s. Now, it's pretty easy to write the diagonal rule maybe on the side of your test, the side of your homework, to kind of keep track. I'm going to show you how to do that at the end, but let's just do an example. Let's do zinc, which has an atomic number of 30, so that means there's 30 electrons. I am going to fill up the diagonal rule, or the electron configuration, until I get to 30 electrons. So the first that I'm going to fill is the 1s, and I'm going to come down through there, 1s, and it can hold 2 electrons. The next chute is 2s, and it can hold 2 electrons. The next chute is 2p, and it can hold 6. And the 3s can hold 2. And then the next chute is 3p, and p can hold 6. And then 4s, it can hold 2. And I'm going to take a breather here and count how many electrons that I have. I have 2 plus 2 plus 6 is 10, plus another 10 is 20. So I have 10 more electrons to account for. So when I go to the next chute, the next thing I fill is the 3d. And d can hold 10 electrons. And so if I add these superscripts, I'm going to get the 30 electrons that are found in the atom. So how do I write this on the side of my paper if I'm working on that? Well, I tell my students that each energy level gets another cloud. So we're going to fill the 1 with an S, and then the 2 with an S and a P. And notice, like, I am keeping all the S's aligned. I'm going to keep all the P's aligned. And now 3 is going to get a D. And then we have 4 with an S, a P, a D, and an F, and then 5, an S, a P, a D, an F, and then I'm going to add G. And you're like, whoa, what? Well, just like I said, we could have 8 energy levels. We can also have more clouds. So after we get another row, we're going to have G, H, and I, and so forth for clouds. So the next one is 6S, 6P, 6D, 6F, 6G, and then we're going to add the 6H, and then 7S, 7P, 7D, 7F, 7G, 7H, 7I. And indeed, if we find more electrons, we're going to add the 8th on down here with the S and so forth. So then you have to draw your arrows in. So you have the 1S, the 2S, 2P, 3S, 3P, 4S, 3D, 4P, 5S. Oops. And we would just continue putting the arrows down through this. Find me on my next videos for examples, the periodic table, shorthand, and so forth. You can find me on TikTok at Kim's Kim Chat and YouTube at Kim's Kim Chat. Talk to you later.